So let's introduce the concept of physical dimensions. In physics, when we talk about dimensions, it's really a description of a general kind of quantity. Now we can also think of this in terms of what type of measurement do you make? After all, making a measurement with a clock is a very different type of measurement than you'd make with a ruler or a thermometer. And these sort of define our types of qualities, or our general types of qualities, our dimensions. Now in mechanics, which is the first part of physics that we study, there's really three basic dimensions that we're going to be looking at: length, mass, and time. And when we use a notation for dimensions, we typically use a capital L, a capital M, or a capital T. Some textbooks just have the capital letter. Some of them put it inside square brackets to let you know that this is a dimension and not a unit or a variable or some other type of notation. These quantities we call the basic ones because each three of these, length, mass, and time, cannot be expressed as a combination of the other dimensions. Length isn't related to mass and time. Mass isn't related to length and time isn't related to length and mass. In contrast to this, we have the compound dimensions, which are quantities that can be related to a combination of these fundamental basic dimensions that we just looked at. To really explain this, let's take a look at an example of speed of your car per se. Let's say it could be measured in units of miles per hour. That's the typical one we use here in the US as we're driving around on the interstates. Well, if you look at these miles per hour, that's really a combination of something which is measuring a length and something which is measuring a time. So our dimensions for speed is really a length divided by a time. And it could be miles per hour, but it could also be inches per second. So the specific units are different, but each one of those all have the same basic type of measurement of a length per time. Now, since I mentioned units, let's take a look at what is the relationship between dimensions and units. Any physical quantity you want to measure, whether it be a length, a speed, a density, it has a dimension that goes with it. Might be a basic dimension, might be a compound dimension, but there's one dimension that's assigned to that type of physical quantity. Every measurement you make of a physical quantity has to have a unit that goes with it, and that individual measurement has one specific unit. But for any dimension, there are several possible units. So when you're measuring a physical quantity, you can measure it in different units, but they have to agree with the dimensions for that physical quantity. Again, let's look at an example here. Say I'm measuring something about time. Well, here's some possible units. Some of these, like hours, minutes, and seconds, they're okay. Any one of those measures the dimension of time just fine. But kilograms doesn't work. So when we say there are several possible units for each dimension, there's a select list that's okay, but then there's other ones that don't match that dimension. This is our basic overview of physical dimensions. Now we're going to take a look at the individual three ones that we're going to be using most in mechanics.